DD is a command on Unix and Unix-like operating systems whose primary purpose is to convert and copy a file. On Unix, device drivers for hardware and special device files appear in the file system just like normal files. DD can also read and/or write from to these files, provided that function is implemented in their respective driver. As a result, DD can be used for tasks such as backing up the boot sector of a hard drive, and obtaining a fixed amount of random data. The DD program can also perform conversions on the data as it is copied, including byte order swapping and conversion to and from the ASCII and EBCDIC text encodings. The name DD may be an allusion to the DD statement found in IBM's Job control language, where the initials stand for data description. The command syntax resembles the JCL statement more than it does other Unix commands, so the syntax may have been a joke. Another explanation for the command's name is that CC was already taken by the C compiler. It is also jokingly said that DD stands for destroy disk, or delete data, since when used for low-level operations on hard disks, a small mistake such as reversing the input file and output file parameters could result in the loss of some or all data on a disk. The DD command is specified by IEEE STD 1003.1-2008, which is part of the single Unix specification. Usage: the command line syntax of DD differs from many other Unix programs, in that it uses the syntax option equals value for its command line options, rather than the more standard, option value or option equals value formats. By default, DD reads from stdin and writes to stdout, but these can be changed by using the if and if options. Usage varies across different operating systems. Also, certain features of DD will depend on the computer system capabilities, such as DD's ability to implement an option for direct memory access. Sending a SIGINFO signal to a running DD process makes it print I/O statistics to standard error once and then continue copying. DD can read standard input from the keyboard. When end of file is reached, DD will exit. Signals and EOF are determined by the software. For example, Unix tools ported to Windows vary as to the EOF, Cygwin uses CTRL-D, and MKS Toolkit uses CTRL-Z. Following the Unix philosophy of developing small yet capable software, DD does one thing and contains no logic other than that required to implement the low-level decisions based on user-specified command line options. Often, the options are changed for each run of DD in a multi-step process to empirically produce desired results. Output messages: the GNU variant of DD as supplied with corridors on Linux does not describe the format of the messages displayed on standard output on completion. However, these are described by other implementations, for example that with BSD. Each of the records in and records out lines showed the number of complete blocks transferred plus the number of partial blocks, for example because the physical medium ended before a complete block was read, or a physical error prevented reading the complete block. Block size: a block is a unit measuring the number of bytes that are read, written, or converted at one time. Command line options can specify a different block size for input reading compared to output writing, though the block size option will override both IBs and OBs. The default value for both input and output block sizes is 512 bytes. The count option for copying is measured in blocks, as are both the skip count for reading and seek count for writing. Conversion operations are also affected by the conversion block size. For some uses of the DD command, block size may have an effect on performance. For example, when recovering data from a hard disk, a small block size will generally cause the most bytes to be recovered. Issuing many small reads is an overhead and may be non-beneficial to execution performance. For greater speed during copy operations, a larger block size may be used. However, because the amount of bytes to copy is given by BSA count, it is impossible to copy a prime number of bytes in a single DD command without making one of two bad choices: BS equals n count equals 1 or BS equals 1 count equals n. Alternative programs permit specifying bytes rather than blocks. When DD is used for network transfers, the block size may have also an impact on packet size, depending on the network protocol used. The value provided for block size options is interpreted as a decimal integer and can also include suffixes to indicate multiplication. The suffix W means multiplication by 2, B means 512, K means 1024, M means 1024, 1024, G means 1024, 1024, 1024, and so on. Additionally, some implementations understand the X character as a multiplication operator for both block size and count parameters. For example, a block size such as BS equals 2 times 80 times 18B is interpreted as 2 80 18 512 equals 1,474,560 bytes, the exact size of a 1440 KIB floppy disk. Uses: the DD command can be used for a variety of purposes. Data transfer: DD can duplicate data across files, devices, partitions and volumes. The data may be input or output to and from any of these. But there are important differences concerning the output when going to a partition. Also, during the transfer, the data can be modified using the CONV options to suit the medium. An attempt to copy the entire disk using CP may omit the final block if it is of an unexpected length, whereas DD may succeed. The source and destination disks should have the same size. The non-error option means to keep going if there is an error. The sync option means to pad the output blocks. Master boot record backup and restore: it is possible to repair a master boot record. It can be transferred to and from a repair file. To duplicate the first 2 sectors of a floppy drive. To create an image of the entire x86 master boot record. To create an image of only the boot code of the master boot record. Data modification: DD can modify data in place. Overwrite the first 512 bytes of a file with null bytes. The no trunc conversion option means do not truncate the output file that is, if the output file already exists, just replace the specified bytes and leave the rest of the output file alone. Without this option, DD would create an output file 512 bytes long. To duplicate a disk partition as a disk image file on a different partition. Disk wipe. For security reasons, it is sometimes necessary to have a disk wipe of a discarded device. To check to see if a drive has data on it, send the output to standard out. To wipe a disk by writing zeros. When compared to the data modification example above, no trunc conversion option is not required as it has no effect when the DD's output file is a block device. The BS equals 4K option makes DD read and write 4 kilobytes at a time. For modern systems, an even greater block size may be beneficial due to the transport capacity. Note that filling the drive with random data will always take a lot longer than zeroing the drive, because the random data must be rendered by the CPU and/or HWRNG first, and different designs have different performance characteristics. On most relatively modern drives, zeroing the drive will render any data it contains permanently irrecoverable. Zeroing the drive will render any data it contains irrecoverable by software. However, it still may be recoverable by special laboratory techniques. The shred program provides an alternate method for the same task, and finally, the wipe program present in many Linux distributions provides an elaborate tool with many ways of clearing. Data recovery: the history of open-source software for data recovery and restoration of files, drives, and partitions started with GNU-DD in 1984, with 1 block size per DD process, and no recovery algorithm other than the user's interactive session running one form of DD after another. Then, a C program was authored October 1999 called DD Rescue. It has 2 block sizes in its algorithm. But the author of the 2003 shell script DD-RELP that enhances DD Rescue's data recovery algorithm, now recommends GNU-DRescue, a C++ program that was initially released in 2004 and is now in most Linux distributions. GNU-DRescue has the most sophisticated block size changing algorithm available in OSS, Drescue, and GNU-DRescue. GNU-DRescue is stable and safe. Another open-source program called Savid7 uses a sophisticated algorithm, but it also requires the installation of its own programming language interpreter. Benchmarking drive performance. To make drive benchmark test and analyze the sequential system read and write performance for 1024-byte blocks. Generating a file with random data. To make a file of 100 random bytes using the kernel random driver. Converting a file to uppercase. To convert a file to uppercase. Creating empty files of arbitrary size. Create a 1 GB sparse file, or resize an existing file to 1 GB without overwriting. A more modern tool for this is Fallicate or Truncate, both shipped with GNU utils. Limitations. Seagate documentation warns, certain disk utilities, such as DD, which depend on low-level disk access may not support 48-bit LBAs until they are updated. Using ATA hard drives over 128 GB requires 48-bit LBA. However, in Linux, DD uses the kernel to read or write to raw device files. Support for 48-bit LBA has been present since version 2.4.23 of the kernel, released in 2003. DCFLDD. DCFLDD is a fork of DD that is an enhanced version developed by Nick Harber, who at the time was working for the United States Department of Defense Computer Forensics Lab. Compared to DD, DCFLDD allows for more than one output file, supports simultaneous multiple checksum calculations, provides a verification mode for file matching, and can display the percentage progress of an operation. See also, backup, disk cloning, disk copy, disk image, list of Unix programs, notes. References. External links.